So welcome students. So in this question, you're given that you have two statements. The first statement is, if you have a circle S is equal to 0 cutting a hyperbola xy is equal to 4 at these 3 points, then the fourth point will be 1 by 4 comma 16. And the second statement is, if a circle cuts this hyperbola xy is equal to c square at 4 points whose parameters are t1, t2, t3 and t4, then the product of the parameters is equal to 1. You have these two statements. Just need to check whether they are true or false. So let us first check the second statement. It's a theoretical statement. So let us assume that you have a circle x square plus y square plus 2gx plus 2fy plus lambda is equal to 0. This is a general circle. So let us assume that this is cutting the curve xy is equal to c square. So it might cut it as many number of points that it needs. And so let us say that to find the points of intersection, let us take a parametric point on the hyperbola. That is, if you have a hyperbola xy is equal to c square, let us say that you have some circle. The center need not be origin. You have some circle which cuts the hyperbola at 4 points. So now let us assume that the point of contact has a parameter t. So if that is so, this point has to satisfy this equation. So let us check what should happen if this t has to lie on the circle. That is c square t square plus c square by t square plus 2gct plus 2fc by t plus lambda should be equal to 0. So if you take the LCM, so c square t power 4 plus c square plus 2gct cube plus 2fct plus lambda t square should be equal to 0. That means if you write it effectively, so you have c square t power 4 plus 2gct cube and you have lambda t square plus 2fct plus c square is equal to 0. So this is the condition which t has to satisfy so that the point has to lie on this circle. Now this is a 4th-degree equation. You can have a maximum of 4 solutions. That means a circle can cut the hyperbola xy is equal to c square at 4 points. So let the 4 points have parameters t1, t2, t3 and t4. Now these will be the roots of this equation. Now to find the exact roots of this equation is out of question because you don't have any given numbers. It's an analytical problem. But what you can see is, so what is the product of the roots of this equation? What is the product of roots of this equation? So the product of the roots is the constant term by t power 4 coefficient. So I don't know individual t1, t2, t3, t4, but the product of all these parameters have to be c square by c square, which is equal to 1. So the statement 2 is true. The product of the parameters should always be equal to 1, whatever happens. Now, if you go to the first statement, here you're given the 3 points, and you're asked to find the 4th point. Now, as you can see, xy is equal to 4 is nothing but 2 square. So according to this question, c is equal to 2. So now the parametric point on this hyperbola is ct comma c by t, that is 2t comma 2 by t. Now if I find the values of parameters of the first 3 points from this equation, I can get the parameter of the 4th point. So if you take 2 comma 2, the parameter is equal to 1. If you take 4 comma 1, the parameter is equal to 2. So if you take 6 comma 2 by 3, the parameter is equal to 3. Now if t1, t2, t3 are known, so how do you find t4? So the product of all the parameters have to be equal to 1, hence t4 should be equal to 1 by 6. T4 should be equal to 1 by 6. So what is the corresponding point? So 2t, that is 1 by 3, comma 2 by 1 by 6 is 12. So the 4th point has to be 1 by 3, comma 12. But it's given as 1 by 4, comma 16. So this is wrong. So first statement is false and the second statement is true. That's the answer to this question. Thank you.